In this video, we're going to look at some simple rules for assigning oxidation states. And what the oxidation state really is you can think of as being the charge of an atom within either a molecule or an ion. So, the rules. 1. If you have a free element, regardless of how many of atoms of that element there are in that pure element, if there's only one type of atom in there, then you are going to have an oxidation state of 0, meaning that it's considered to be neutral. For simple ions like alkali metal ions, alkaline earth metal ions, or halogens or whatever, in ionic compounds, their charges are, or their oxidation states are, their charges as ions. So if you have like sodium chloride, chloride's -1 and the sodium would be +1. The number one rule really though is that when we're looking at these is that oxygen has a charge of -2 or an oxidation state of -2 with the exception of in peroxide molecules where it's -1. Now oxygen you can think of it as having a really high electronegativity. It's the second most electronegative element next to fluorine, and therefore when it bonds with things it's really pulling strongly on the electrons. So what we're really looking at is the ownership of the electrons within a substance. So when oxygen's involved, since it's stronger than virtually everything else, you can consider it to have pulled those electrons in those bonds towards it. And since it's going to be bonded to two things, we then would consider it having a -2 charge. Hydrogen, which has a relatively low electronegativity relative to the other nonmetallic elements, because of that, it's not holding on to electrons very strongly. When it's bonded to other things, you can think of it as giving its electrons away to them. The exception to that is when we're looking at when it's bonded to a metal, like as in sodium hydride. Right? Now the other thing you would have to look at is that when you have a compound that's neutral, the sum of all the oxidation states has to add up to 0. So if we were to look at something like KMnO4, we know that this has overall no charge. So you have 1 potassium, potassium's an alkali metal, you're going to get a +1 charge there. You have 4 oxygens, which each has a -2 charge, so that would be -8. So if we were trying to figure out what the charge of manganese was, you would have to say that in order to make this all balance out and equal 0, you would have to have a charge of +7. So let's take a look at a couple other examples. All right. If we're looking at ammonia, we said that hydrogen is considered to have a +1 charge. So in that case, since this is a neutral compound, then the nitrogen is going to have a charge of, well, you guessed it, -3. Right? And you can think of that probably being because nitrogen has a higher electronegativity than hydrogen, so in those bonds, the electrons are more owned by the nitrogen. When you look at ClO-, this has an overall charge of -1, and since oxygen's -2, you consider chlorine to have a charge or an oxidation state of +1. If we're looking at H3PO4, you have 3 hydrogens, each of those is +1, so that's a total of +3. Again, it's a compound, so we're going to consider it neutral. You have 4 oxygens, so that's an overall charge of our oxidation of number of -8. Each one of those is -2. So what does the phosphorus have to be? Well, it would have to be +5. And this is very similar to what we just looked at, where you have 4 oxygens for a total of -8. Since we don't have the potassium in there, we're going to consider just the ion. So what plus -8 gives you -1? Well, that would have to be +7. Now, this ion right here, you have 7 oxygens, and this overall charge is -2. So if you have 7 oxygens, that gives you a charge of -14. So what plus the -14 would give you -2? Well, that your 2 chromiums would have to contribute a total of +12, right? So that means each one would have to be +6. Now for this next one, it's actually a little bit more complicated because you're going to look and you're going to say, okay, we're considering the hydrogen to be +1, so that would have to, that's going to be considered +8. So your 3 carbons would then have to be, -8. But then you're going to look and you say, okay, so that's -8 over those 3 carbons, which is a little misleading because then you're going to say it's going to be, okay, so that means it's -8/3 or 2.66. But what really happens is, in that molecule you have, and this is propane, 2 of the carbons will take on a -3 charge, the two terminal carbons will, because they're bonded to 3 hydrogens. And they're holding on to the electrons more strongly. So you would say this carbon would have an oxidation number of -3. And same thing for the other end. The carbon in the middle, however, you would consider it only it's equal in strength to those two carbons, so it's not pulling any electrons from there. However, these two hydrogens it would, so therefore this one would be +2. So even though overall it gives a -8 charge, and we could say it's -8/3, I would look at a molecule like this and look at the atoms individually to say what their oxidation states would be.